Hello, everyone, and welcome to the Switch Statement Podcast. It's a podcast for investigations into miscellaneous tech topics.
This is episode 4 in our series on Martin Fowler's Refactoring.
Hey, John.
Hey, Matt.
How are you doing?
I'm doing pretty well. New video game dropped that I was excited about, so I was playing that a little bit.
Do you think that they refactored their code a lot when they were building it? Do you think they had a lot of tests? I
think they had this book right on their desks, and they were consulting it regularly to build this game. You can tell in the end product that
go to sleep.
Highly refactored.
That's good. No, it's good. Because all quality code, refactoring is both a necessary and sufficient condition to write good software, right? Everybody knows that.
Wait, is that a quote? Is that a Martin Fowler quote?
No, I'm just straight off the dome right now.
Oh, man, that was amazing.
Matthew Keller quote.
You just invented that?
Wow.
Yeah, dude. I'm impressed. So yeah, you want to chat about testing?
Let's chat about testing. So we're going over chapter 4 in Martin Fowler's Refactoring, and we're talking about testing. So what did you think of this chapter?
I thought I was going to hate this chapter because I often hate the way testing is approached in our industry, but I actually really like this chapter. I feel like, I don't know why, but I just expected Martin Fowler's viewpoints to, kind of be the company line, like always write tests for everything. But he had a much more kind of pragmatic viewpoint on it. In fact, I wrote a quote down: testing should be risk-driven.
Yes.
Which I really liked. I was like, yes, exactly. It's just such a good way of putting it because so many people are like, 100% coverage, which is obviously dumb. And no, it's like, the coverage should be in the parts of the code that are known to be complex, known to have high risk, known to be important. Really like that phrase.
Sometimes I think was easy to think of Martin Fowler as like overly idealistic about some of his stuff, but this showed him to be like very pragmatic. It's like, no, there's a bunch of people who are super idealistic, and like it's definitely possible to write too many tests, and that's not the angle that I'm coming from. It's like you want to write the tests where you think it's going to fail.
Yes, yeah. It's interesting because the book is about refactoring, so I think whenever he talks about refactoring, he does take on this kind of overly ideal tone, at least to me sometimes.
Yeah.
But since he was talking about testing, it was more of kind of his real opinion, because he's not trying to sell something in this chapter.
That is very funny. But I think you're right. It's like, since it's not a book about testing, he doesn't need to have this overly grand unified theory of testing that he has to espouse. Yeah,
which I super appreciated. He brought up my favorite and what I think is the most important way of testing, which is to, whenever there's a bug in the system, always write a test to reproduce it. There's this concept that I like to call bug recidivism, where
interesting.
The new bug that you're about to have is probably a bug that you've already had, or also likely it's probably in a system that's already had bugs. Bugs have a tendency to cluster together and kind of repeat themselves. So I love the practice of writing a test to reproduce a bug.
And actually, just to piggyback off that, I think a really good model for testing is you start off, and you should be able to come up with interesting cases for the code that you're writing to fail. You should write those tests right off the bat. Right? Yeah. And you should go through the exercise of building up, okay, I have a couple of these pieces of infrastructure in order to write an interesting test, because you're always going to need to kind of jump through some hoops the first time you're writing a test to set up an interesting scenario, right?
Yeah.
And I think it's important that you do that when you're writing the code initially. But you don't need to, I don't think you need to go super exhaustive. And I think Martin Fowler would agree with this, that you don't need to try to think of every single possible way that your code could fail and write every single one of those tests. But then, it's important that you've already done that work because you have this platform where you can add new tests when bugs invariably crop up. And then the test will just evolve in the direction that the bugs guide it.
Yeah, and I completely agree. And there's also a couple aspects of testing that I think a lot of teams and companies don't think about a lot, which I think are like people should think about more. One is that like people never, or at least teams that I've been on maybe, don't spend a ton of time verifying that the tests are actually catching bugs.
Yeah.
Where, a lot of teams I've been on have these epic test systems where it's like, it takes, like the unit tests, they might run quickly or whatever, but then you have these integration tests that run, and they might take like an hour to like fully run. And sometimes they break, and then you have to like go fix them. And no one ever asks the question of like, are these tests breaking because there's a regression in the code? Or are they breaking because, I don't know, some other reason, like some downstream dependency broke, or, maybe they timed out or something dumb. And, tests incur a huge maintenance cost to an organization. And if they're not actually finding bugs and preventing regressions, then why do you have them?
Right. They're negative value because not only are they not finding bugs, but they're a drain on everyone's time because they fail. Everyone knows that the tests are flaky. And then you just run it again because, and which may take, it may take another hour for you to submit this code because you had a flaky test invocation. And so,
yes.
And just in case it's not a well understood term, flaky is like, it will fail for reasons that are unrelated to, the code actually being wrong.
Right, exactly. Yeah, things like timeouts or transient errors.
But no, I think that's very true. And actually, like, my career started as a software engineer in tools and infrastructure, which was mostly around building this larger test infrastructure. And I think, and I'm not sure that I ever achieved this level, but really good software engineers in tools and infrastructure would be able to know when they were writing test infrastructure that was providing that value. But I think a lot of times we got it wrong. We would put this big test infrastructure in place and like no one would ever add tests, or like it would just slow everyone down essentially. So
yeah, no, I mean, I think it's an extremely hard problem, and it's something that's very hard to get right. And it's also, tests are kind of an afterthought, even if they're like quote unquote important to the organization. People just kind of do the bare minimum. And I've definitely done that. I've done the bare minimum. So I think it's super important that the tests be like svelte, as lightweight as possible, run as quickly as possible, not be flaky, because the minute the tests start becoming this kind of maintenance nightmare, people will spend like that bare minimum amount of effort to like add what they need to add. And then they'll just get the hell out because they hate it. So it's important to keep your tests tidy and nice.
I think it's a really hard problem of like, and I mean, I guess you potentially have this problem with production code as well, but a hard problem of knowing when to get rid of a test. Like, should you, like, maybe there should be some sort of like graduation program or something where if a test is not catching bugs, well, like, this is the thing, like there should be a way to determine the usefulness of a test. And I don't have a good way. I'm not going to like try to design that system here, but it would be great if there was a way to be like, or some system that's like, hey, like this test is not interesting. Let's delete it because, I think a system like that would be great.
I think you're actually touching on one of the biggest issues with tests, which is no one will ever say anything against tests. No one's ever going to say, oh, I think we need to delete these tests.
Exactly. Yes.
And the fact of the matter is sometimes maybe you should. Like if you have a bunch of tests that take like an hour to run and they're from an old system that's, maybe doesn't get a lot of use or isn't that important to your overall organization, you should maybe consider deleting them or at least making them run every like month or something. I don't know. I think these types of issues should be talked about more because there's kind of this weird taboo around tests where, you always got to write tests for your stuff, never delete tests, always run all the tests. And it's kind of all these, it's a religion. Yeah. And I just think that type of thinking can be dangerous because you're not thinking pragmatically or scientifically about it. You're kind of following these weird maxims.
Dogma.
Yeah.
It's a dogma of testing. And I think Google as an organization is very extreme on the spectrum. They are very test heavy. And I think to Martin Fowler's point here, moving in the direction of having too many tests. I remember one of my kind of higher ups, in the testing org saying that, the engineers or the SREs came to him and said, well, okay, we can either run the production system or we can run these big integration tests. We don't have enough computing resources to run both of these things. So, which is like obviously like farcical, but like that was kind of the reality of the situation. These tests were consuming a tremendous amount, especially because, as you say, like they're supposed to run as close as possible to every single change, potentially multiple times per change.
Right.
And so when your test takes an hour, like that's an incredibly expensive operation. So you can see kind of how it can get that bad. So.
Oh yeah. On the topic of tests being a religion, I was curious what you thought about test-driven development.
Oh my gosh, you stole my question. You stole my question, dude. Because I was going to ask you the exact same thing.
Okay, well, you have to go first.
I have never done test-driven development. And I don't want to go too far I don't think test-driven development should ever be done. Like, I'm not going to go as far as to make that claim. I think he alludes to a potential middle ground, which is you write the production code, you write a test, the test hopefully passes, and then you make sure that the test fails before, like you go in, you kind of inject the fault, as he describes it. You make sure that the test fails because it's way too easy to write a test that's trivial and doesn't actually test anything.
Yeah.
And so I think like that's kind of what I would say. Like I think sometimes I find it hard to, like until I've at least done some of the implementation, like I think I can find it hard to even reason about what the test should be.
Right. Yes. Yeah, and this would be my major feeling against test-driven development because, I think it all depends on the situation. There's definitely cases where you're writing some new service and it kind of has this well-understood, super intuitive interface. And maybe in a case like that, test-driven development makes a ton of sense. But I have definitely, at my first company before Google, we actually did test-driven development for a while. And I totally hated it. And maybe it was because I was a new engineer. I just wasn't as good at like API design. But I would write the tests, start writing the code, realize that I wanted to like completely change my APIs or like restructure things. And I would literally have to like rewrite the tests.
Yeah.
And it was just this massive pain. And I don't know. I definitely came to the opinion that I thought test-driven development was kind of silly. I do think there's probably cases where it's really, really useful. And I do like the idea of writing a test to fail and then like, writing the actual code to fix it. It's kind of similar to that whole, like, if there's a bug, write a test for it to reproduce it. But yeah, not a big fan of test-driven development overall. But I think it has its place maybe in the overall process.
What I will say is I find a lot of times I write the code and then I go to write the test, and it actually does have significant effects on the production implementation of it, which are positive ramifications of doing the testing. Mm-hmm. But like it just feels like it would be really tough to do it out of that order.
Yeah, maybe it is a mental shift that, does pay dividends, if you can make that mental shift. But I don't know. I think it's tough for people who haven't done it a lot. I think it might be tough.
The other thing that I wanted to bring up is like the idea of like rapid prototyping. Like, I feel like testing is kind of, runs counter to a process of like doing rapid iterations of prototyping.
Yes.
Where like maybe you're really not sure. This is something I've said. I'm not sure if I said it on this podcast, but it's like tests are momentum, right? And I think we've talked about this. It's like,
yeah, I love this concept.
Which momentum is not a good thing or a bad thing necessarily, or by itself. But if you start writing a bunch of tests in a particular direction, and then you realize after you're coding for a while, like, oh, wait a minute, I need to do this big refactor, restructure, what have you. But like sometimes that restructuring like changes the way the tests work. Mm-hmm. So like I think in an idealized case, like of what Martin Fowler is proposing, the tests work regardless. And then you can do your refactoring and the tests stay the same, right?
Right.
But there's so many times where you wrote your test in a way, and maybe this is just a bad test, but you wrote your test in a way that now the implementation has to change, and now you have a bunch of tests that you need to update. And so like that seems to be like one pitfall that I feel like you can get into if you do test-driven development, where it's like, maybe you don't know enough about what this implementation is actually going to look like to start writing good tests against it.
Yeah, no, exactly. I like to say that tests are a client to the code. And they come with a lot of the same trade-offs that new clients come with. Like it's harder to change your external interfaces because you have some client depending on it.
Yeah.
And yeah, sometimes if your behavior is changing, then the clients need to update in order to respond to those changes in behavior. So it's and I am a huge fan of rapid prototyping, which you mentioned earlier. I think like when a project is just starting, it's so important for the code to be flexible and for just massive sweeping changes to be able to take place. And I don't know, I've worked at companies where we literally did not write a single test. I probably should not admit this in public, but when I was at Instagram, I think I wrote like 3 tests in my entire time at Instagram. And it was kind of amazing because there was times where, the way Instagram's culture works is you experiment features, and if they don't do super well, you try little things. You tweak the feature here and there. You add like more animations, or, you just try to juicify it a little bit. And that type of thing, those types of changes are just way easier when you don't have tests, because you don't have this kind of client depending on your code. So I thought it was great. And Instagram has an amazing QA system, which another thing that I wanted to point out is I think tests are awesome, and I do really like tests, and I think they catch a ton of bugs, but I don't think they can replace QA.
No.
I think QA is just vital to a proper development process. Whether it's just engineers testing their own stuff or whether it's just ideally, a separate team that tests stuff. So yeah, I thought that was interesting. It was just very culturally different from Google, but also very effective in different ways.
I mean, especially when it's very client heavy. There's a lot of interesting things out there about UI testing, but it's definitely not a solved problem. There's a lot of kind of like varying opinions about how to do UI testing.
Definitely.
One thing that I kind of wanted to get your opinion, did you read through the code? So just to take a step back, in this chapter, he gives a very simple example, which is kind of arcane. Like, I found it hard to parse. You're like a Roman emperor, and you're trying to figure out the grain production ability of your your empire.
I just read this code yesterday morning, but I do not remember what the code was about at all, which I think is probably feeds into your point about it being arcane.
Well, yeah, I just found it very, very difficult to reason about, since he chose the least relatable. It's like, say you're a Roman warlord, and your fiefdoms are producing a certain amount of grain at a certain price. Amazing. I was like, all right, maybe do something from this millennium. That would be a useful way to connect with your readers. Do you have the book?
I do have the book. Yeah, let me bust it open.
I want to turn your attention to the production setter. So he has a function, set production.
Oh, wow.
And I just wanted to maybe get your thoughts about this function.
Oh, I hate this function. I hate the plus equals. Is this function meant to say you're like producing this? Like if you call it multiple times, should it like be additive?
Well, this is what's interesting. So yeah, there's this field, or well, he wants it to look like a field. But you like you set some value to this production, and a lot of stuff happens when you set this value.
Yeah, I do not like this for many reasons. First of all, it's a setter and it has a bunch of logic. But second of all, I would expect it to be setting a value. Like if I call it multiple times, it's not like doing some side effect. Yeah, exactly.
Yeah. Which the point that I'm getting at, and exactly what you're saying, like there's way too much logic in this setter. There's a point later on where he says, oh, this production setter, like there's quite a bit of logic. Let's test this setter. And what I would say is like the point at which you're writing a test for your setter, it shouldn't be a setter anymore.
Yeah.
Like setters should be very, very simple. Like only just the most basic checks. Maybe if you want to prefer an existing value if they're equals, just for like reference equality or something like that. That's the main thing that I wanted to call out.
No, I agree. This function looks insane. I'm surprised it's not a code smell from chapter 3.
Yeah, and potentially that's his point is like, oh, like this is why you want to test in this scenario, and then you can refactor this setter so that it's not quite as insane.
Yeah.
I mean, I guess you could wind up with a scenario where you're overriding like an interface that has a setter, and then you do like there is some interesting logic that you want to happen when someone calls your setter. But anyway, like this stood out, as you're saying, as a code smell to me. It's like testing your getters or setters, like, nope, you don't. That's a bad scene.
The item potency thing too, it just seems insane. Like I would never be setting some field equal to something and expect it to like increment some other field. Like that just seems wild.
The reason why I feel strongly about this, it's the principle of least surprise.
Yeah.
Right? When someone is calling your setter, I'm assuming that they think that it's a very straightforward operation. Mm-hmm. You know, with like some well understood assumptions about like what goes on when you do that. But like if you are hiding a bunch of logic behind your setter, you're really violating that contract, in my opinion.
Absolutely. Yeah. It's definitely not the first time either that I've seen the code in this book and been like, what? Like, I think I'm just stylistically very different from Martin Odersky. Or, sorry, Martin Fowler. Who's Martin Odersky?
I don't know.
Anyway. He's I think he's...
goaltender for the New Jersey Devils.
I think he's one of the creators of Scala. Which, this is not the first time I've tried to think of the author of this book and thought Martin Odersky. Anyway,
we should just say random other famous computer scientists every time we are trying to say Martin Fowler's name.
Well, I know I always want to say Kent Beck, and we've already discussed how Martin Odersky is just stealing all Kent Beck's best ideas. But
you said Martin Odersky again.
Oh my gosh! Okay, we need to cut this part. This is horrible.
No, this is going in. This is staying in.
I forgot what I was even talking about. Yeah, so his code samples seem weird to me, but I think I'm just stylistically very different from Martin Fowler.
I think that was mostly it. I mean, maybe it's late to be bringing this up, but I think at a high level, what I would say about this chapter is it would be really useful for someone, and I think we keep on coming back to this point, but someone who's newer to software engineering, I think this book would be incredibly valuable, especially if the company that they're working in doesn't already have a really strong testing culture.
Yes. Yeah.
But I think, once you're in the field for a little while, like you're going to get exposed to these ideas. Like he talks about he introduces the idea of a test that says like whether or not it passed.
Yeah.
Which
that was
which
hilarious.
is it's funny because like I guess there was a time where the automated testing would still print out a result and you would need to like read the values of it to double check that it was right.
Yeah.
But so like all of that is to say that like he's introducing some fairly basic concepts for someone who's been working in the field for a little while. But I do think, like, I want to go back and say, like, for someone who's new, like, I think there's a lot of unintuitive things here that like you wouldn't just discover accidentally when you were going about programming.
I agree. This was actually one of my favorite things I've read on testing. I thought his opinions were all very pragmatic. He threw out all of my top ideas that I like to think about regarding testing. And yeah, it was just really interesting.
I think that's pretty much it. Did you have anything else you wanted to?
No, I don't think so. Yeah, this was a nice short and sweet chapter. So we can keep the episode short and sweet.
So just a note about the rest of the book. So the rest of the book is now the catalog of refactorings. So we're going to kind of lump all of those remaining chapters into one big, long super episode where we just pick and choose our most interesting refactorings. So for the next episode, it's going to be kind of like a grab bag of interesting refactorings.
Yeah, that'll be fun. We'll have some good stuff to talk about.
Yeah. All right. Well, I will see you next time, John.
All right. See you next time, Matt.